Here's the review for this chapter. Way back in the first section, we talked about ways to solve a problem, right? We set up kind of a system, and you would go through this system. Now, we said that you probably didn't go through this step by step with every single problem. In a sense, you do, but you really don't. Right? So, that process was exploring it, planning, solving, and then examining. When we explored it, we read it, we tried to figure out what was given to us. We set up a plan, meaning, how the heck are we going to try to solve this? Do I have enough information? Do I have too much information? We solve it using math somehow. And then examining it would be to see if the answer made sense in the first place. And maybe in equations, you could actually go through and correct it. Okay? So, again, do we do this per se every single problem? Probably not. If you flip the page, what kind of problems were 6 through 12? Or sorry, 6 through 9. What did we call those kind of problems? Patterns, or if they gave you a bunch of numbers, we could call them a specific what? Begins with an S. It was like a pattern, like Caden said. A sequence. There you go. A sequence. And a sequence was like an elaborate pattern because it was specific. There was either it was going up or going down by a certain amount, right? So if we look at number 8, for instance, what's happening in number 8?
It's being multiplied by 3.
By 3 every single time, right? And then they could go on and say, in this case, find the next term, and I just do it again, right? So what would be my next term?
62 times 3.
Go for it. What's 162 times 3?
375.
No, it's in the 1,000.
475.
No, it's not in the 1,000.
In the 1,000? Are you serious?
It's
Hold on, I can do it. I
I
can do it. It should be 6.
And then it'd be 12.
No.
No, stop. Just wait. It'd be
6 times
486.
No, I'm trying to.
486.
No, it's there.
Oh, I was
486.
You gotta carry the 1.
Alright, so understood sequences or patterns? We're just trying to find what's going on. Second section was about numbers and expressions. What was an expression? What was an expression in math? There's a problem without an equal sign, right? And in order to do this, we used what acronym? PEMDAS, right? We used PEMDAS. This was the order that we had to go through in order to solve the problem. So my P is my parentheses. Okay, so here we have two kinds of parentheses. Usually the real parentheses go inside the brackets. We'd have the curly Q ones for sets and that kind of thing. We also talked about absolute value bars, vertical bars, for another kind of special set of parentheses. What was my E? Exponents. And what does that really mean? Yeah, all right, you do it next. But what do you do if you do exponents? That's the little number. And what's that little number tell you? To multiply the big number. What's the big number called?
The base.
The base. So take the base times itself, the exponent number of times, right? And then we said M and D have the same power and A and S have the same power. M and D are, and we always work left to right like we're reading. And then finally we do addition and subtraction and again left to right. Okay, so look at the problems 11 through 16. Any of those you want to see on the board?
16.
That is pretty complicated.
Perfect.
It's not complicated.
Go ahead. Tell me what it says.
4 bracket 9 plus parenthesis 1 times 16 parenthesis minus 8 bracket.
All right. All right. So
68.
where are we going to start?
1 times 16.
We're going to go inside. So remember, anytime that we have multiple sets of parentheses, we work inside and out. So 1 times 16 is
16.
So we should rewrite everything else basically. Now what are we going to do?
Left to right, so you do 9 9 plus 16.
9 plus 16 is
25.
25 minus 8.
17.
17, what's 17 bracket 4 mean?
Times
17.
Do it.
17. 68.
16. Agreed? Can I really check this one? Probably not. Okay. But you did good, right? Any of the other ones on that section? Remember like in 14, we called these a giant fraction. So remember, just because it says division, we actually want to do everything on the top, then everything on the bottom, and do division last. So that one, it's special because we don't actually go in that order of operations. Any others in that section? Perfect. Next section, we just introduce variables. What was a variable? A letter that, what?
You didn't know what.
Either we didn't know what it was or it represented a number that we could put in there, right?
Yeah.
Remember, an expression then was still using problems that didn't have an equal sign. Now we could just put variables in there. And if they put a variable into the problem, but they don't give you what that variable stands for, the problem is really the what? The answer, right? I can't solve some of those things. But if they give it to me, then I have to substitute it in there, and that's kind of what they do in this section, right? So 17 through 22, any of those you want to see. Remember now, we're starting to get into algebra mode, so remember things like on number 20, what does 6x really mean? 6 times for multiplication, is that correct? So again, any of those you want to see? We're just taking what they give us in the directions and sticking them into each one, right?
Can you do 21?
I can do 6y over x plus 9. Okay, so here's my problem. What was y? What did they tell us?
8.
So 6 times y is 6 times 8 divided by what is x?
3.
3 plus 9. So, where are we going to start? We're going to do the division, right? Or the division sign, but we got to do the top. So 6 times 8? Still 48. 48 divided by 3?
16.
16 plus 9.
25.
What?
Questions? There, you're getting a haircut over there. I know. So,
He gets a movie.
No, he said he's gonna buzz cut.
yep, tomorrow.
Give him a bowl cut.
Next section. Or do you want to see any more on that section? Next section was about properties. I'm not going to lie to you, there probably won't be a whole lot of this on the quiz or the test. This was just more of us kind of introducing a name for things that we already knew, right? Our basic ones were commutative and associative. Basically a lot the same, we could reorder them. Associative was more with parentheses to group things. But what operations could we only do this with? When does the order not matter? When I do what two things?
0 and 1.
Or you can like flip flop them?
Yeah. What operations can I do that with?
Associative.
No, we can do that with the associative, but what kinds of problems? Addition and multiplication. The order doesn't really matter, right? If I take 2 times 3 or 3 times 2, I still get 6. But it matters in subtraction and division. Okay? So that's what commutative and associative meant. Then we went on to the additive identity. How did we identify numbers with addition? We added them to what? 0. Anything plus 0 got me back to that number. And what did we do it with multiplication? We called it.
Anything times 0 is 0.
We did 2 of them. Anything times 0 is 0, so it doesn't matter how many things. If 0's in the problem and we're multiplying it, gets a 0. Or multiply it by 1 and we get back. So we had the multiplicative identity was with 1 and multiplicative property of 0 was with 0. Okay? Next one was basically what we did today because we did it out of order, was the variables and equations. And the only real difference between these problems and what we did for today is today they had an equal sign, right? And then we had those open sentences where we could put them in there and figure if they're true or false, or really easy ones that we could just mentally see and do. But we'll get more into that next chapter. Okay? Any of those on 27 through 32? Turn the page. So the next thing that we looked at was our coordinate plane, right? And the coordinate plane is an important part of what we're going to get into later on with graphing. So when we have our coordinate plane, remember, we are talking about this, and our yellow axis was called the what? The Y, so the green is the X. And they form ordered pairs, right? The X always has to come first. So I'm always thinking about going right or left. Now in this chapter, we only concentrated on this top upper right corner. But each one of them were called quadrants. Exactly right, Michael. So we started here with 1, and then we went left 2, 3, and 4, and we always have to write those as what? Roman numerals. What is Roman numeral 4? IV. Don't write them as numbers. Okay? From there, then, you might be given a point with a letter on it. That's just naming that point. So where is R?
Over 7, 6, 9.
Over 7, up 9. So it would be 7, 9. When we do this, don't forget to get graph paper. I'll give you graph paper. Don't forget to get a ruler to draw nice straight lines. And don't forget to put numbers on your coordinate planes. What happens if I have Z here? What are the coordinates for Z?
0.
0 what?
What number?
9.
0.
9, 0.
That would be 0.
10.
Is it 10, 0 or 0, 10?
0, 10.
10, 0.
10, 0, right? 10 because we went right. X is right. We didn't go up. Right? Now, what quadrant is Z in?
It's not in one.
It's not, so you can say none, or you could say what?
0, 0.
The x-axis. Okay? Do not say between 1 and 4. Okay? And don't write them as regular numbers. Write them as Roman numerals. Okay? So you might have to plot them. When you plot them, don't forget to put the capital letter there because you're what? Naming them. Okay? And then the last section was about scatter plots, right? Remember scatter plots? What was that about? Well, we're basically just making a fancy diagram or coordinate plane. And what were our 3 ways that our scatter plot could tell us information? Positive, negative, or nothing, right? Positive ones would go in what direction? Yeah, so we'd start down here and it'd move up to this right-hand corner. Negatives would be up here and going down. That was just the relationship that the information taught us. But don't get fooled. Sometimes positive ones aren't good, right? And sometimes negative ones are. Just depends on what the information's telling us. And then when there's no relation, like Mike said, then they're just all over the place. Okay, there's no random like order. And then remember, this was the one we actually had these dots up here from our bread one, the example in class. And this one actually went down or was negative a little bit and then was positive. But that would have been one that's probably not as good for us because when it's going to has a positive relationship, it meant the bread was what? Gaining price. So it wasn't necessarily a good thing. So that was our scatter plots. I know you definitely have to do a scatter plot for the quiz, but I don't remember if you have to do one for the test. Okay. So, any questions with any of that? Hopefully that's a lot of kind of review and introductory stuff, so hopefully we fly right through this quiz. And the way that some of us take quizzes, we might do both the quiz and the test tomorrow. Because you guys go pretty fast. But if not, that's no big deal. We'll take 2 days. Okay? So, questions?